Okay, part 6b. What value of the constant k does f have a critical point at x equal 1? Stop right there. F has a critical point, we memorized earlier in the year, when f prime is equal to 0 or undefined. So I've got to go back to part A and get my f prime value. So I'm going to write that down. So I write f prime of x. You wouldn't have to rewrite it on the actual test because you could see from part A, because you have a booklet, k over 2, x to the negative 1/2. Minus x to the negative 1. I need to figure out when this is equal to 0 or undefined. Well, oh wait a minute. For what value of k does f have a critical point when x is 1? So I get to plug in x equal 1. That helps a lot. So f prime of 1 has to equal k over 2, 1 to the negative 1/2, but 1 to any power is just 1, minus 1 to the negative 1, 1 to any power is just 1. So this is k over 2 times 1 minus 1, and that whole thing has to equal 0. So the value of k has to be 2. Because 2 divided by 2 is 1, 1 subtract 1 is 0. So this particular problem, I earned 1 point by figuring out that I needed to plug in 1 and set it, actually 2 points for that. So I figured out with this pink material right here, by plugging in x equal 1 and knowing that f prime of 1 must equal 0, that was 2 total points. Finding the value of k is another point, that's 3 total. The justification. Now I keep reading. For what value of k does f have a critical point? So I found k. Oh, I read this wrong, sorry. Checking the answers here. This was 1 point. So doing this earned me 1 point. Solving for k was the second point. Now it says for this value of k, determine whether f has a relative min, relative max, or neither at x equal 1. So I've got to figure out, does f prime change positive to negative at x equal 1 when k is equal to 2? So I need to take my f prime equation. We're going to make some space here. So the f prime equation now is f prime of x. K we know is 2. So we have 2 over 2, 2 over 2, x to the negative 1/2, subtract x to the negative 1. I've got to figure out if f prime changes positive to negative near x equal 1, so that's a sign chart. Cannot do a sign chart with negative exponents, so we're going to change those. So really what we have is one over square root of x minus 1 over x. But I know that on my sign chart, at x equal 1, this is going to equal 0. So I just need to test either side now. So plug in something bigger, something I can take the square root of, like 4. So f prime of 4 will equal, the square root of 4 is 2, so this will be 1/2 minus 1/4. That's equal to 1/4. That's positive. I can't plug in 0. That's undefined. Can't plug in a negative number. That's also undefined. So I have to plug in something that I can take the square root of, like 1/4. So back up. F prime of 1/4 is going to equal 1/, square root of 1/4 minus 1/, 1/4. That's equal to, square root of 1/4 is 1/2. 1/1/2, subtract 1/, 1/4. You invert and multiply, so this becomes 2, subtract 4, which is negative 2, so this is definitely negative. So we definitely have a situation where f prime is changing from negative to positive, hence f will have a relative min. So we have to write that out. We say at x equal 1, f prime changes, again this wording is on the back of the golden notes, from negative to positive. So f has relative min at x equal 1. This statement will be worth 2 points, 1 point for identifying relative min, and a second point for all the wording, which gives me the justification. So this part, this FRQ 6B, is worth a total of 4 points.